Alright, question 50 for Practice Provincial B. A cylinder with a diameter of 10 centimeters and a height of 12 centimeters is half full of water. So in reality, we're really only dealing with a cylinder of water that is 6 centimeters high and a diameter of 10. Into this, we add a ball with a diameter of 5. We want to know how far up does it actually go. Alright, this is a problem that deals with volumes of different shapes. Okay, how do we know it actually is a volume problem? Well, when we add things to water, or when we're dealing with a container full of something, it usually means we're dealing with volumes of some sort. So that's one clue. Now, we can do this in this method. We need to know first the volume of the water, then we need to know the volume of the ball, and then we need to know what is the volume of the ball and water. Okay? Because as you know, when you add things to water, the height of the water ends up rising as you add more things to it. And this is just the principle of displacement. So if we add the volume of the ball to the volume of the water, then that will force the height of the water to go up a little bit. That's what we're interested in, just how high up does it actually go. So the volume of the water we can calculate using the volume of a cylinder, pi r squared h. This will be pi times, the radius is 5, because it's half the diameter, times 6. This will be 150 pi. 5 squared is 25, times 6 is 150. The volume of the ball will be 4/3 pi r cubed. This will be 4/3 pi, and the radius of the ball is 2.5. So 2.5 cubed, 2.5 cubed is 15.625 times 4, 62.5, 62.5, and 62.5 over 3 times pi. Right. This means the volume of the ball in the water will be 150 pi plus 62.5 over 3 pi. And if I simplify that, I will get the following. 450 over 3 pi plus 62.5 over 3 pi. And I'll get 512.5 over 3 pi. That's the total volume of the ball in the water. Now, why is this quantity important? Well, when we add the ball to the water, there's the train again. There's my ball. Okay. The water is still a cylinder of radius 10, or diameter 10, and height h. So this volume is just the volume of yet another cylinder. So I can say the following. 512 over 3 pi is going to be equal to pi r squared times h. Okay. Well, we know that we can see that the pi's cancel out immediately, and we know r squared is just going to be 5 squared, because the radius of the cylinder is 5. So I can cross that out, replace it with a 5 squared, and then we just solve for h. So when we solve for h, we'll get 512.5 divided by 3 divided by 25 equals h. So h is going to equal, let's calculate this out, 512.5 divided by 3 divided by 25. H has a height of 6.83 centimeters. Okay. Looking at our answers. Well, the question actually asks us how far will the water level rise. We have the total height. If the water started off at 6 and went to 6.83, it went up a total of 0.83 centimeters. And let's check, make sure we do this correct. So, whoops, that was question 50. 50 is B, which is what?